Hello and welcome to this online course on Chemical Engineering Thermodynamics 1. Myself Dr. Sunny Kumar, Assistant Professor in Department of Chemical Engineering, PKG College of Engineering and Technology, Panipat. My presentation outline is Introduction to the Syllabus of the Thermodynamics, Course Outcome, Syllabus outlines and the recommended books, and some initial fundamental topics of thermodynamics. The purpose of this chemical engineering thermodynamic is to understand the basic of thermodynamics and PVT behavior, laws of thermodynamics, thermodynamics relations, concept of power and refrigerations. So this is the purpose of the chemical engineering thermodynamics 1 syllabus. The course outcomes will be to introduce with the basics of fundamental thermodynamics and the PVT behavior, pressure, volume and temperature behavior, to formalize with the laws of thermodynamics, to familiarize with the concept of thermodynamic relations, to familiarize with the concept of power and refrigeration cycle. So this is the outcomes for this syllabus. The syllabus of this subject is it has 4 units. The first unit is introduction and the PV behavior. The second unit is laws of thermodynamics. In the third unit, the thermodynamic relations. In the fourth unit, the power and refrigeration cycles. In the unit 1, the concept of work, heat, CP and CV. CP and CV is specific heat, which is maybe at the constant volume and constant pressure, and the open system and the closed systems, extensive and intensive properties, internal energy, enthalpy, entropy, PVT, pressure, volume, temperature, behavior of the pure liquids, viral equation, cubic equations, general correlation, throttling process, Joule-Thomson coefficients. These things we will read in unit 1. And in unit 2, the laws of thermodynamics, energy equations for closed system, steady flow process, limitation of the first law, Carnot cycle, and concept of available energy, path, state, and reversibility and irreversibility. So these are the in unit 2. In the unit 3 is thermodynamics relations like Maxwell's relations, Halmos, Gibbs functions, TdS equations, Clausius-Calpern equation, and what is the application of these equations. So in third unit we will use this. And the fourth unit is power and refrigeration cycles, the Rankine cycles, air standard cycles, vapor compression cycles, Otto cycles, Brayton's cycles, refrigerant and their properties, liquefaction of gases and generation of power from heat. So these things we will read in the unit 4. So this is your 4 unit syllabus, and the books are which is recommended for this syllabus is YVC Rao, Chemical Engineering Thermodynamics, which is the University Press, the Smith and Vance Introduction to the Chemical Engineering Thermodynamics. This is very common book which is very useful for the chemical engineers. All the syllabus is covered in this book. B. Bhattacharya and S.C. Bera, Engineering Thermodynamics and Fluid Mechanics, the title of this book. And the Radhakrishnan, the author Radhakrishnan, the written by the Radhakrishnan, and the book name is Fundamental of Engineering Thermodynamics. Publisher is PHI, and then last one is the Engineering Thermodynamics, the PKN. This book you have already read in your first year, I think. Previously you have also known about this PKN, which is Engineering Thermodynamics. So these are the books which is recommended for the chemical engineering syllabus. So now we will introduce what is the thermodynamics, and the thermodynamics as is now can apply for the variety of problems covering the physical and the biological science. In thermodynamics finds extensive application in chemical engineering. The field of chemical engineering is commonly divided into unit operation and unit processes, and how we can utilize we will read in this subject. The thermodynamics as a words combined with thermo and the dynamics. Okay, so the thermo means the thermal behavior generally we think, and the dynamics how the after the thermal behavior what is the effect of this. So this is the example. So how this train is moving by the steam engine train. So simple water create a steam, convert into the steam, and then it creates the temperature pressure. By the pressure it moving the it create the mechanical motion generally we generated by this. This is a perfect example of this. So it means getting the motion or power due to the thermal interaction, and this was the scope of thermodynamics, running or rotating a wheel by exposing it to steam with high temperature and pressure. So this is a perfect example, steam engine. It is the function according to the H.C. Van Ness. It is the function of thermodynamics to relate those properties of a system required for practical or theoretical purpose to the parameters that are the most readily measured, and thus to provide the maximum return of information for any investment in experiment. So it is caught by the H.C. Van Ness. So in chemical engineering generally you have read the two subjects, the thermodynamics and heat transfer. They generally relate to each other. So what is the difference between them? So the thermodynamics deals with the equilibrium states and changes from one equilibrium state to the another. But in the other way, in the other hand, the heat transfer deals with the system that lacks of thermal equilibrium, and thus it is a non equilibrium phenomena. So and it is a rate, generally we consider in the rate how much time it is required for the heating of this. Okay, so now the scope and the limitations of the thermodynamics. The chemical process can be predicted using the thermodynamic calculation. So we have to know about what is the maximum work obtained from a specified change in the state of the system, or what is the minimum work required to effect a certain changes in the system, and what is the efficiency with which work is produced when a certain fuel is burned in a steam engine. The example we have already shown previously. These answer of these questions are provided by the thermodynamics. Thermodynamics sets a certain limits to the various processes occurring in the nature. It helps to determine the purpose of the process, and it deals with the direction of changes and the equilibrium conditions. For example, in the blast furnace, the thermodynamics can predict the equilibrium yield of the reaction and also give the insight in the driving force for the changes under the given condition, temperature and the pressure. Iron is produced by the reduction of iron oxide by the carbon monoxide. The carbon oxide, you are seeing this reaction, which is iron oxide reacting with the 3 carbon monoxide, and we are generating 2 iron and CO2. Gas leaving the chimney contains considerable amount of CO carrying away the utilized heat. So the question is how we can increase our CO conversion for production of maximum iron. So we have to make a long furnace, the height of 30 meter. So and the reaction is equilibrium limited. We can control by the this, if you know about the thermodynamic use. So according to the Lee Charter, they said the enormous sum of money was wasted which could have been prevented if laws of thermodynamics were applied. So now we will discuss about some fundamental concept of thermodynamics. The first is we have to define the system and the process. So what is a system? In thermodynamics, a substance or group of substance in which we have special interest is called a system. So you are seeing which is bound by the using this boundary. This is a system. It is the part of the universe is set apart for our special consideration. It may be reaction vessel, a distillation column, or heat engine. The process, it changes taking place within the system is referred to as a process. Whatever the happening in this system, which is called the process. Thus the hydrocarbon fuel and the oxygen in combustion chamber constitution the system, and the combustion of the fuels from water and carbon monoxide constitutes a process. Okay, so now the part of the universe outside of the system. Outside the parts of the universe outside of the system and separated from the system by the boundaries is called surrounding. Outside this system is called the surrounding. The boundaries may be either physical or imaginary. They may be rigid or movable. For practical reasons, the surroundings are usually restricted to the portion of the universe which is in intermediate vicinity of the system and are affected by the changes occurring in the system. For example, when the steam consideration in a shell and tube heat exchanger is treated as the system, and the cooling water to which the heat vaporization is transferred may be act as surroundings. Okay, so the next one is, so we have discussed the system, process and surroundings. Next is homogeneous and heterogeneous system. So the homogeneous system, this system is also called a phase. The properties are the same throughout, or process properties are very smoothly without showing any surface of discontinuity. So this is a example of homogeneous. Liquid water in a beaker and a column of dust free air above the earth's surface are example of homogeneous system. So this is also, the cup of tea is also a homogeneous system. In heterogeneous system, this is a system which consists of two or more distinct homogeneous regions or phases. Suppose this is a bowl of flakes in milk. So the flakes is a one component and another is milk. So these are separated. So this is a heterogeneous system. A liquid mixture of benzene and water forms a heterogeneous system made of the two immiscible liquids phases. Okay, so these are some examples of homogeneous and heterogeneous systems. Now we will talk about the closed and open system. The system that can exchange energy with surroundings but which cannot transfer matter across the boundaries are also known as closed system. As you seeing in this is a no energy transfer is happening. The open system can exchange both energy and the matter with their environment. So this is the open system, energy and mass can both transfer. This thing and this one, the cup of tea, if it is put by some plate, so it will be covered by the plates. It is a closed system. So this is a open system, this is a closed system, so you can see very easily. The next one is the isolated system. This is a system which is totally unaffected by the changes in the environment. There is no mass and the heat transfer occurs. So these three, the yellow ones block, and this bottle, and this is an example of there is no heat and mass transfer is occurring. That is a isolated system. Okay, so these are some examples of closed, open, and the isolated systems. The next one is the state and properties. Certain specifications such as pressure, volume, and temperatures are necessary to define the condition of a given system. So suppose this is a system, and these are some properties: rate of change of mass, or pressure, temperature. These are some conditions are given. These are the properties of the system. The conditions defined for a such specified is called the state of the system. The thermodynamic property serves as define the state of the system completely. So this is a well-known example. So by this we can do some calculations, and we can know about them. The variable used to define the state are called the state function or properties of the system. The minimum number of such variables required to represent the state uniquely depends on the number of phases constituting in the system, the number of distinct chemical species present in the system. The properties generally used to represent the state of homogeneous system consisting of single substance are the pressure, volume, and the temperatures. So this is a state and the properties. So today we have discussed about the 3-4 topics. The first is fundamental, what is the thermodynamics, and the second one is what is the difference between the thermodynamics and the heat transfer, the scope and the limitations of the thermodynamics. So how we can utilize this thermodynamics for the different chemical processes, what are the examples we can. So in the blast furnace, the iron oxide is reducing into the iron, and so how to define a system and the process, and what are the surroundings and how they affects the system, like in shell and tube example we have given. The homogeneous and heterogeneous system, so these are the two examples of homogeneous and heterogeneous systems. And what is the closed and open system and the isolated system. So these three are the examples of isolated, closed, and open system. The state and properties, so this is a perfect example of we can define how the properties affects our systems. So these are the properties: mass, pressure, and the temperature. Thank you. Today this is today lecture now completed. In the next video we will read about the other part of the other topics of the thermodynamics. Well, thank you.